I'm going to give you an assignment which you are going to do a framing and show me tomorrow, which is a two-story building, as you can see this one here. So this one now should be your assignment. So do this framing, do the GA, put your grid lines and column positioning on this plan. As you can see that this plan has a ground floor, a first floor, and then a pen floor, as you can see it here. So and also has a cantilever, as you can see that. So make sure you check your plan very well, study it, and then do the same thing that I've just done just now. As you can see, I did this from this plan to this very way as it is here. I did my panel 1, everything, panel then. So do the same thing that we have done today, as you can see for this one, so that when you're done with this design, this is the one you begin to to do your practice. Why I'll be the one guiding you on this one, then you now be the one doing this by yourself. So that let me see how your hands is going and also how you're learning. So make sure you study this plan very well. As you can see that it has several cantilevers. This is a cantilever, small cantilever here, and on this pen floor, you can see that this is a roof below. So this is the only place that has building on this pen floor. So make sure you study it very well. And then when you also get to this so make sure you do it very well. So share your screen. Let me see if you have seen those two files which I just sent to you. So I'll stop sharing now. Now share your own screen. See, okay, that's fine. Okay, so check your mail. Let me see if you have seen that. Check your Gmail. Let me see if you have seen that. So if you're interested to join our Ekidel Mentorship, I will say check on the link down below and then enroll for your Ekidel Mentorship, and we will train you basically on structural design. Okay, so basically, this is the first class, which we are going to start with a one-story building, as you can see it here. So basically, this is a plan that came from the designer, let me say, architect, as you can see it here. It's simply a one-story building having a ground floor and a first floor. So whenever you get your drawing like this, or your building plan, and then you want to begin to now perform the full design, the first thing to do before you can begin to perform that structural design is to first of all understand the plan. And when I mean by you understanding the plan is for you to know the features that came with the plan, such as cantilevers, and then as you can see, this one have a circular columns, as you can see that. Then also you have to also check if the ground floor plan and the first floor plan, if they are the same, or if they're not the same, what is the what is the this thing between them, difference between the two. All right, so right now this is how my plan came. So before I'll begin to do that, it is good for you to copy out that plan first and get a copy of that. In case you make any mistake, you can always refer to the main one, original one. So with this now, since I've made a copy, I'll just come here right now and then form a boundary about this. So this now becomes the main plan, and this now becomes the one I am working with. So now, as you can see right now, as I said again, the first thing to do is to now study your plan. As you can see from this ground plan now, if I want to study this end plan now, I have seen that there is an inclined wall here, as if it's a slanty wall. That is one thing I've seen. Then two, I am seeing a dash line here, which basically once you see a dash line in any plan, or most times solid line, but just a single line without any thickness, it means that that line is a cantilever. Yes, cantilever slab there. And also it is also here too. So once I see these two, I'll just refer to the first floor plan, and then you can see how the shape is also. So basically this is a cantilever, and also on this place too, here is a cantilever around the staircase. So now I have known that there is a cantilever slab on this building. That is That's the one thing I've seen again. Then again, you can see that there's a circular column that came with the plan, that came with this building plan. Basically, this circular column is to give beauty to this building, as you can see here. So on no account will you go and remove these columns, circular columns that came with the plan. So whenever you have a column that comes with a plan, always keep it. So right now, and I also see that these three columns now, only one is going up. The rest is just stopping at the slab. As you can see that this one here is not on this first floor plan. So basically, it is meant to stop at the decking or the slab. And if you check on our view here, you also see that too, that this column here, circular column, stops directly at the slab. As you can see it here. And then the one also at this back also stop at the plan. Most times people don't used to study their plans here. Once they get that their plan, they will just begin to put their columns and grid, and then now export it to the software Protastructure, which in that place now they will not begin to waste time, because it is there that they will not begin to now study their plan, which most times they will begin to have issues in their designs. Okay, so right now, since I've known that there's a cantilever and also circular columns, these two stoppings at the slab, and also there is an inclined this thing here. Now it is now time for us to now begin our GA drawing. So to now begin your GA drawing is to be done on the ground floor. So like I said, GA drawing simply means column positioning, paneling, and also how your beams are like going to run. So I'll begin my GA drawing now. Since I'm using that software, Protastructure, I'll have to create two layers. I'll call the first one grid, and I'll call the second one column. So I'll go right now to create layer, and then I'll just create those two layers. I'll just click on the new layer, and then click on this one and name it grid. And I can choose a color if I want, or you can just leave it to any color you want. So I'll just choose yellow, and I'll say okay, and I'll go again right now again and click again and create another one again and call it column. So that software needs you to have these two layers for you to be able to see these two elements. Now when you export this plan to the software, it will see this grid now as an axis, and this column as a column member. Okay, so right now on the same column here, I'll choose my column line thickness. I'll just choose 0.5, just for it to be very, very visible, although that one doesn't matter, but the main thing that matters is to name this one grid and then column. Okay, since I've named these two now, I will now come here and then close. So if I come here right now on my layer list, you can see that we now have grid and also column. Now on this one right now, since we have the grid and column, I will first of all begin to insert all my grid lines. Now before you insert your grid lines, make sure that this place is by layer, which is the color. This color control is by layer, and this line type by layer, and this line weight by layer. Most times you might have something like this. It's not good to have, because one, if you have something like this now, that means that your grid line will not take the color of that color that was set on this layer. So always leave it by layer, by layer and by layer and by layer before you can now start. Okay, so since I've done that now, since I know that I am meant to do my GA drawing or my GA drawing on the ground floor, so I'll just copy out this ground floor out from this place. I'll copy it out now. So since I've copied it out, the next thing to do is to remove all the features, like all these furniture features, bed features, and all that from your plan, because GA drawing is meant to be very, very, very clean and not meant to be having all these furniture symbols. So right now, I'll just take off all these furniture symbols that came with the plan. So we are not trying to now make this plan right now to now look like a structural plan framing. So I'll just remove everything that came with this plan, which is all these toilet symbols, and this chair should be off, this table should be off, and all that should be off. Dimensions can be off too, and this one should be off. Now I don't like someone to take off doors, because if you go and remove doors, you might not mistakenly go and put column where the doors are. So always leave doors first until you're done putting all your column points. Can you hear me? Okay, let me make your voice to start coming out. I think I didn't do that before. Let me just do that now. Um Coming. Let me just open up. Okay, let me. So can you hear me? Let me know if you can hear me. Okay, so right now, to now begin to create my grid line, since I've already removed all the bed furnitures, dining furnitures, and sitting furnitures, I'll now begin to now create my grid lines. So I'll go here right now and choose grid. As you can see, I'll just choose grid layer. Okay, then I'll now do XL. XL simply means construction line. So when you're drawing your grid, always don't use line like this to draw your grid, else it will not show on that software Protastructure. So always use construction line XL and then enter. Now since if I want to start with my let me say vertical, I'll just type V and then enter. Automatically I will be seeing my vertical this is my vertical and grid lines now showing. So I can choose now go to like the vertical wall here and place it vertically on the center of that wall. So as you can see right now, I have just established my first my first grid lines. So I'll just copy this right now, CP or CO, copy, and then choose a reference point here. Since all the walls are almost the same thickness, which is 9 inches, I will now begin to now place it at the same reference point, and then all the grid lines will just start just be placing at those grid lines at those walls. So I'll just use now the whole idea is to divide all the vertical walls now with a grid line. Okay, so I am done with this one now with all the verticals. Can see there. I will now go again, XL, enter, H, enter. Now H is to draw for the this thing for the um horizontal grid lines. So I will now locate again at the midpoint of the wall. Now, if you can't find the midpoint of your wall, you just type L, which is line, enter, and then divide this wall into two, and then now type XL, enter, H, enter, and divide, and now place it at the midpoint of that place. Okay. Now I've just placed my first line again, grid line, which is the H line, and that H is for what horizontal. So I will now choose also a reference point here and begin to place it. Now, if you have any question, let me know. Can you hear me? Okay, so I begin to place it right now and place it here and go again at this place and place this here. Go again at this dining area and place. So the whole idea is to place all your grid line, all your walls should have at least a grid lines. Okay, so I'll place this here also, and then place this here, pick this point and place this, and then pick this last one now. Okay, so right now we are done with the whole grid lines, as you can see it now. Okay, no, sorry, we are left with this. So I can just go and copy this one, CP or CO, and copy from here to here. Okay, that's fine. So since I used since I used this kind of line to draw my grid lines, this XL line doesn't have an end, as you can see there, doesn't have an end. So I'll have to trim it now off. To trim off this line now, I'll just create a boundary, which is rectangle, using a rectangle rec, enter, and then create a boundary just with an eye gauge, create a bit boundary around this building. When I create the boundary, I will now select on that rectangle and type TR, enter, and then begin to trim off these ones all the lines that are beyond that that rectangle which I've just created, and I'll now click on the rectangle now and then delete it. Okay, so right now you can see that we have gotten our our grid lines on this plan now. Okay, most times too, I like to remove this staircase and just use a void to show it, but I can just leave it first as a staircase as it is first. Now it is now time for us to now begin to play. Yeah, can you hear you? Can you hear me? Yeah, can you hear me? Yes, I can hear you. Okay, that's fine. XL, 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 yeah, XL, enter, then V, enter. Okay, look again now. If I want to place a grid line here now on this wall, I will just first of all use a line first. Use a line, which is L. Line means L. Enter. Divide this wall into two by using a line first. As you can see what I'm doing right now. Then right now I have gotten this. I will now take XL, enter, V, enter. V means vertical. I will now come and place at the midpoint of that line which I just created. Then I will now remove this one which I created now. With that, I've gotten this center. Can you see that? Okay, so let me just take this off because I'm not doing that now. Okay, so that's how we have created our vertical grid lines and also our horizontal grid lines, as you can see that. Okay, so right now, the next thing to do is to now begin to place our columns. It is from this column now that we now begin manual, like manual principles, which you're meant to know. Okay, so now I will now go here and change to my column layer because we are done with this grid. I'll now come and change to my column layer. Okay, now on this column layer right now, basically a default size of column is should like be the size of the wall. Should be able to fit. Yes, either if your wall size is a default size of column, either you use 2 by 230 or you use 225 by 225. They are still the same because it's just a small difference. Okay, so right now to now place my first column, what I just do is to click on rectangle. Always use rectangle when you're placing column, else it will not show on the software. If you use a line just now, a line, and then form your column like this, let me just use a like this and form your column something like this, something of this nature. I'm coming, something like this. If you do if you do this now and then copy this column and go and paste inside this point where you want to put your column, that software will not be able to see this as a column because this column was drawn using a line. That software needs your column to be as a single unit. As you can see that this line is not a single unit because it has different let me say bodies. Can you see that? Segments. So basically, you are meant to use a rectangle icon to create your column. So if I use a rectangle now to just create my column, I click anywhere and I type 225 tab 225 and enter. Sorry, let me just escape. I want to try two rect now. Rect still means rectangle, and I click any point there. I type 225 by 225. Okay, you can still use tab because most times most keyboard doesn't use to take comma as the by. So I can use rectangle again. Rectangle, click at any point, and I type 225, and I'll use that tab your tab key, tab, then 225, and I'll press enter. So if I measure this now, you can see that this is 225. Let me just measure that now. This to this 225. As you can see that here 225 by 225. But let me just measure here. But the whole idea is to use a rectangle icon to create your column. As you can see, this one right now has like it's like a single unit. Why this one that was use line to create has different lines. Can you see that? Hello, are you with me? Okay, that's fine. So right now, that's how to create your column elements if you want to export your drawing to the software Protastructure. So right now, I'll just go here and click. Now, since I have my wall here, the best way to just insert your column, either you use that 225 by 225 and draw it and then copy it, or just come here to where the wall is, click on the first wall here, click on the first wall here, and then click on the last on this other point here. It will just fit in the column inside the wall immediately. Can you see that? So with this now, I can just copy now, copy, which is CP or CO. CP or CO means copy. I can just use, then copy from the center point here, from the center point of the column. Now, I want to now begin to now put my column points. Now, when you're putting your column points for the first time, you can just put your column point first randomly. But later, it is required that your column spacing between two columns at least should not be more than 6 meters for the, like, let me say, for the main time. Then when the person is a bit experienced, you can go as far as using column to column distance 8 meters, 9 meters, 10 meters. But for someone beginning design newly, our advice you like keep your column distance up at least maximum 6 meters. Because what happens is that when your column distance exceeds 6 meters, what happens is that the size of the reinforcement for the column will like begin to, like, let me say, increase. Either you begin to have 4y20 as your column reinforcement, or the size of the column will now go and increase. Instead of 225, it now be around, let me say, 225 by 300. And also the depth of the beam running along that span of column will also increase either by 600, because when your beam length exceeds 6 meters, it is that depth of beam will like increase to up to 600. Like if you have a 7 meter or 8.5 meter beam, you can't use a depth beam of 450, which is the lowest depth of beam to use for like a floor beam. You can't use that. So for someone beginning design, that's why not to have these kind of failures in your design. Always keep yourself around below 6 meters as your column distance. So I always advise you just keep yourself between 5.5 or 5 meters, so that at least you can have your columns to be at least having 4y16, and your beams also 4y16 maximum bottom. Although you can still have 3y16 at the bottom and then 2 at the top. But when your column distance begin to exceed more than 6 meters, then at that point you will now begin to have either to add layers of your bars on the beams. That you have 2 layers of bars at the beam bottom or at the beam top. That's because you have now exceeded 6 meters. Okay, so knowing that now, I'll just begin to place my columns first of all randomly. Then after, I will now measure those distances. Then also, when you have a cantilever, as you can see that we have a cantilever here, it is good to put a column at the end of your cantilever. What I mean by end, as you can see that this cantilever ends at this point. So always have a cantilever at the end of the always have a column at the end of the cantilever. Reason because at the end of this cantilever, there will be a high moment at this place. So if you don't have a column at the end of the cantilever, and let me say this cantilever length is up to, let me say, 1.5, 1.8, 2 meter and above, what happens is that it will make this beam to like twist. It's just like when you carry your right hand and hold your left finger and try to twist it. You understand what I mean? So it not try to twist the beam. But if you have a column at that point, column will be able to like stop, or let me say carry that kind of effect from the cantilever. Okay, so since I have a cantilever here right now, I'll just put a column at that point, which I've put, and also I'll also copy the column again, copy again here, the column again, and then come to this point again where I have my cantilever ending and put here. But basically, since this cantilever length is not that long, I think this is just 600, I can choose to not to use it. But I'm just telling you like the principle of if you have a cantilever, you're meant to have columns at the both ends, as you can see that what I've just done now. And then I'll do the same thing here. Let me just do the same thing here. Since it's a cantilever here of 900, just to follow that same guiding principle, I'll put a column here and also put a column at the, okay, there's a column here already, which is a circular column. So I'll leave that there. Okay. Now I will now begin to just place my columns. I'll place this one here also. I'll place this here. I'm coming. Place this here. And then, sorry, you means undo. Let me say you like did a slight mistake. You just type you enter. It just undo what you have done before. Okay, let me just come back now and then put this here. Can you hear me? Okay, I'll put that there. And also I will now put this one here. So now column position depends solely on you. No one will tell you how to position your column. So that's why you're meant to know how to position your column very well. And if your column point is not well framed, or let me say at the best position, that's where you begin to have issues on your modeling. Now also the reason why you're meant to learn column position too is because if you're doing for a pi foundation, the way you like put your column points, if you're doing for a pad foundation is different from if you're doing for a wrap foundation, and it's different from if you're doing for a pi foundation, because pi foundation requires rules about spacing of pies. So if your columns are too close to each other, that your pi foundation cannot work because it will fail in spacing for the pi. Can you hear me? Hello, let me know if you're with me. Hello? Yeah, are you with me? Okay, so as I was saying, sorry, let me know where you stop and stop hearing me. That is what I'm saying. Where did you stop hearing me? Start from there. Okay. So what I was saying is that again, that the way you put your column points or do your GA, when I mean GA, I simply means column points and then framing, how your beams are running and then slab. So the way you do your, yes, I say the way, exactly. So the way you do your column points for pad foundation is different from the way you do your column points for a half foundation, and also different for a pi foundation, right? Because okay, I think that would be if I try to enter that place now, it just carry us away from what we are. But just know that the way if you're doing a half foundation, you are meant to study your column points very, very well. Because if your column points have issues, then your half foundation will have issues also. But if you frame your structure very, very well for a half foundation, you won't have issues on your design for the half foundation and also for the pi foundation. Okay, so right now, but now we are using a pad foundation for this. That's why we can just put our columns anyhow. But even if I say anyhow, you are still meant to know all the principles. So right now, I'll also put my column point here first. Now we have just put all the whole external columns. Now let's now begin to now put all the internal columns. Okay. So right now I will see if as you can see that from here to this point is a bit long. So I'll just go and establish one column point here. I think, and then that's all. Yeah. So, but most people will can go as far as putting a column here and a column here, and then go and now remove this one. Okay, most people can see do that too. So basically, column points or your framing depends solely on you. So right now that we have done placing all our column points, it's not time for us to now begin to measure our column distances if they conform with that guiding principle of column point below 6 meters as a beginner. Can you hear me? Okay, so right now let's now begin to now measure. I'll just change to any kind of let me just change to this one and then click on dimension. Let's now begin from here, from this column to this column. This is 3225. Okay, that's fine. It is below 6 meters. That's okay. And from this point to this point, this is 5.17. It is still below 6 meters. Yeah, which is still okay. Then I'll go again here from this point to this point. This 3.445. That's okay. Basically, this column, I would have taken off this column if I let me check from here to here. This is 5.7, which is still below 6 meters. But the reason why I'm leaving this column is because of this cantilever end. That's why, yeah, that's why I'm leaving it. Else I'd have taken it off. Okay, so from here to here also is still below 6 meters. And then from here to here is below 6 meters. Now, basically, most people will say, why am I putting this column here? Why not just span the beam from here to these points? As you can see, this is 4 point something meters, right? Now, I always advise people, whenever you have a fancy column, like a column that came with a plan to give beauty to the to the building, always establish a structural column nearby. When I mean structural column, like a column that will be able to hide inside the wall nearby. Because this column basically is just here to give beauty to this building. Maybe after they have finished all the building, let me say, finish the whole building, this thing, like finish the whole building, construction. The client might just come up over the years and say he doesn't want this column again, and just take it off, without knowing that you now use this fancy column as the main column to carry the load around this place. So he will know that. So that's why I always advise that you should put a near column closer to that fancy column, so that you don't have issues in case the client choose to take it off later or not. At least you still have a column that will be able to carry the load around that place. Do you hear me? Okay, so that's why I will leave this column here. Else I would have taken it off, because from here to here is below 6 meters. But just because of that reason, I will leave this one there. Okay, and then I also have a column here. So let me now check from this point to this point. That's 3.7, which is less than that. From here to here, that's 4 point something. I'll leave that. And yeah, then from here to here, that's 4.5, 4.4, sorry, that's okay. And I believe this should be less than that also, and this one also less than that. Okay, now let me begin now check this internal one. So always check your column distances, because now the reason why I always advise you to know your column distance is because if you have done this, like let me say 3 to 4 times in your designs, you can be able to, once you see any kind of design, let me say drawing, or let me say if they are building any kind of structure. Can you hear me? Okay. The reason why you are meant to master this your column positioning very, very well, and also study your column distances, is because over the years, if you've done it like, let me say, up to 10 times, 7 times, you've done designs a lot using the same principles. Let me say someone just carry you to site any day, and then you just see at the site, you just see a column distance with your just like your eye gauge, without you checking the drawing. You can be able to know the kind of reinforcement that will run along that beam. That's because you have already known that any column distance below 6 meters, and let me say, if it is not and if that building is not carrying heavy load, like let me say a church building, shopping mall, if it's just a normal building, then that beam should be able to carry 4y16. So if you see them putting 4y20 for that kind of short distance, you should be able to query them without you even going to check that design. That's because you have done it over the years, and you have seen that any column distance below 6 meters should be able to give you at least maximum 4y16 bottom, and let me say 3y16 top. That should be the maximum. Okay, so knowing this right now that I have done my GA, as you can see it now, I have done my GA just now. I have checked all my column distances and everything. Everything is okay. Now, we will now move into paneling. Paneling simply means how you want your slabs to run. Slab also have guiding principles, because if you fail in your slab paneling, then your buildings will begin to have issues, if either during the design or after they have finished the building construction. It now begin to have issues. So now let's now begin paneling. So to panel your building simply means how you want your beams and your slabs to run. So there is a rule like in slab paneling. BS code states that the area of a panel or a bay should not be more than 30 meter square area. So when I mean by a panel or a bay, if I want to use this place now as a panel, BS code states that, in fact, not only BS code, even US code, Indian code, and every other code states that the area of a panel or a bay should not be more than 30 meter square area. Now, what happens? Now, you would have to ask a question: what happens if the area of a panel is more than that? Now, when I mean by the area of a panel no more than that, you only have that rule if your panel length is, let me say, 6 by 6. So 6 times 6 will give you what? 36, right? So if you have your column distance now at one point, let me say at the length here, 6 meters, and here again 6 meters, basically the panel of that place is already more than what the code says. So the only way for you to be able to guide yourself within that principle is to now establish what they call a concealed beam, or you call it internal beam, along that panel to be able to break that span. So most times, most people that don't know all these principles, you will see them going a span of, let me say a bale of, or let me say a panel of 8 meter by 5 meters, or 8 by 6. And 8 times 6 will give you around 40 something, right? Yeah, thereabouts, or 40, thereabouts, for something, which is already more than what the code says. Now, if they go ahead and go and build that structure, and maybe that structure isn't standing, what happens is that for you to be able to what happens is that if you want to overcome that, you either go and increase your slab depth to up to 200 or 750 of that slab depth. Can you hear me? Okay, you either go and increase the slab depth of that panel from 150 to 175 or 200. But if you still go and use 150, what will happen is that if that structure didn't fail during the design, after the whole building like the whole building process, I don't know if you have gone to any building before. Maybe those days when you are in school, maybe you're on the ground floor and somebody is at the first floor. Mistakenly, somebody throws a plate or a cup at the slab, or let me say at the decking. You you that is at the ground floor will like hear the sound. I don't know if you've been in that kind of building before. Eh? Okay, two things makes that sound to pass through the slab. One is when that panel area is not meant based on the BS codes. Two is if you design your slab bar spacing to, let me say, 200 or 150 or 175 bar spacing for your slab bars, and then during the construction they not gonna use a very large spacing of, let me say, 300 or 350. Yes, those kind of things will cause that kind of issue. It will make the slab to be very, very porous, and sound will be able to pass through. That is if that slab does not deflect. So that's the kind of effect you're not going to have in that building, and which is not good for like let me say anyone living in that kind of building. Okay, so right now, knowing that your area of a panel should not be more than 30% area, so I'll now begin. Since I have checked this already, I've already checked from this point to this point. This is 5.1 meter, and from here to here is 3 point something. So 5 times 3 will give me around let me say 15 point something, right? So with this now, I can choose to remove this toilet wall or beam. I can choose to remove this now because I want to make here as one panel. I'll remove this now, remove this door, and extend this my beam line now, which is from this staircase. Extend this and remove this line. I can choose to join this one here. So basically right now I have gotten my first panel, so I can come here and call this panel 1 and call this P1. So I've gotten my first panel. So what I've just done right now, most people also that don't know this rule, you see that small building will like be very, very expensive to like build. That's because, let me say, if me and you right now is doing the design, and you choose to use this toilet wall that was there before as a beam, and here also as a beam, basically me that have taken it off, I've just reduced the cost of that building by taking those two beams off. Can you hear me? So if me and you right now is like trying to bid for this project for a client, your own might be, let me say, 20 million to finish the whole building, and mine will be like, let me say, 17.5 million. Basically, that client will just stick with me because my own is a bit lower, and also if they check the whole design, it is still okay. That's because I know the rules of this paneling and also guiding principles in designs. Okay, so I can just choose to remove this window, and then I just extend this. So I've taken this now as my first panel. Extend this. Use J to join. J means join this. Click here and join this. So I'll remove this dimension now. Okay, so here again right now, I can check this again, this panel. Let me know if I'll choose this terrace and this kitchen as a panel. So first of all, before you choose, check if they are within that guiding principles. So this to this, which is less than that. So 3 times 4.5 give us around, let me say, 12 point something, or let me say 13, which is less than 30. So I'll take it off right now and then remove this, and take this now as a panel also. Remove this. Yeah, can you hear me? Hello, can you hear me? Hello. Okay, so I said I just checked. Yeah, I said I just checked this now. These two panels, they are less than that rule. So I'll take this off right now and make this as a panel. Can you hear me now? So I'll call here now. Okay, so I'll call here panel 2 because I have checked that, and then they are within that rule. I can choose to extend this my line just to cover it up and cover this up. Remove this window symbol and then cover this up. Okay, this and this. Okay, I can choose to remove this door now because I've already positioned all my columns, and then use extend this line into this place, into here and into here. Okay, now this dining I can choose to leave here as a panel because dining to this main lounge has an arc. So this arc will still be a beam. So I'll just call here panel 3. Hello, are you with me? I like notice that you are off. Hello, are you with me? Okay, sorry for that. Okay. So right now I have just taken this dining as panel 4. Can you see that? So since you already know the guiding principle of your paneling, so just use that principle anytime you're doing your design, and then follow that principle. Okay, then this now let me tell you about this place. Are you there with me? Okay, now for this inclined wall now, or this this for this inclined wall now, most people will go and use it as a beam and go and form an inclined beam there. But for me, I will just take my beam to run like this and like this. And then later, during the building construction, they will just use wall, a block wall to form this shape. All right. Okay, so let me just take off this off and take this off first and this off. So I'll just use this now. I'm coming. So I'll just use this now and extend my beam line into this place and into this place first, and this also done to connect with this column, and this done also, and this done also, and then remove this inclined wall now because I already said that they will use a block wall to form that shape during the construction of this building. Okay, because my own here is just to design the building is to just design the building structurally. Okay, so I'll take this again, extend and extend also. So I'll call this right now panel this panel 4, P4. Okay, this P4. Then I will just take off this door and extend my line, this beam into this place and into this place. Sorry, into this place too. Okay. Then here I will also take off this door here and extend my beam here into this place too, and take off this one. So basically I will have now this staircase now I will use a void symbol and void it. Whenever you see the kind of symbol like an X, this X symbol simply means a void. So I'll use a void now and void and then take off this staircase symbol that came with the plan. Let me just take it off. Okay. So I've now taken this now as my staircase void. Can you see that? Yes. So right now I'll call this guest bedroom now as panel 4. Panel 4. Sorry, panel 5. This is P5. And I'll call here P6. P6. I'll take off this right now off and extend this and this. And take off this door and extend this and this. Now, by doing this now, basically you have already done more than, let me say, 40% of what you would have done on the software Protastructure. Because once you go to the software now, all you have to do is just to trace your beams as you have placed it here. And in less than 5 minutes, you are done with the whole design, because you have already studied the whole plan and you have known how you want everything to run, how you want your beams to run, and how you want your slabs to like be, as you can see it here. Let me take off this fancy cladding for these columns. Take this off. That's fine. Okay, I can choose to extend this here, extend, cover this up and cover this up and cover this here, and remove this. Then I can choose to put this place here as a small panel, which is within this lobby. I can choose to call it panel, this panel 7. Okay. So basically, this is how to form a can you hear me? Okay, so basically we are almost done with our GA, which is the main framing. So Most times I spend up to 1 hour doing my framing. That's because I know that if I get it right, when I move this plan to the software, it won't take time again. Highest 10 minutes or 5 minutes, I am done with my whole design. But if you don't do this here, it is now when you're going to the software, you now begin to spend time and study how your beams are going to run. Now, once you're done with because as you know that we did this on the ground floor. Let me copy the ground floor again. We did this on the ground floor. So once you're done with your GA on the ground floor, it is good to now superimpose your columns on the first floor. The reason why you're going to superimpose the column, because most times where you put your column point here might be, let me say, appearing on empty space on the first floor or on the next story. So always superimpose your columns on the first floor or second floor to see which column will I stop at the slab, and the columns that will I continue to the roof beam or to the next floor. Can you hear me? Okay, so right now I'm going to copy my columns now and then superimpose them on this first floor to see the columns which are going to stop directly at the slab and the columns which are going to continue to the next floor, or let me say to the roof beam. So right now, when you're copying your column, always choose a reference point that is the same with the first floor, ground floor, or second floor, or let me say another story. So right now, it is best to choose staircase area because staircase point doesn't change from floor to floor. Can you hear me? Hello, are you there? Okay, I said when you're copying or when you want to do a superimpose of your columns on your ground floor to your first floor, it is best to choose staircase area as a reference point when copying all the columns because staircase area does not change. But most times, staircase area might be difficult for you to like pick because let me say if I want to pick this point now as my reference point, if I go here right now, it has changed because this place has a cantilever. So I won't be able to like get it right here. So it is always good to choose the place where there is no change. So in these two plans now, which is the ground floor and first floor, in this particular plan right now, this point here and this point here didn't change because there's no cantilever around this point. Can you see that? Can you see that? Okay, so now if I pick this point now as my column point, like my point of reference to like copy and paste it here, those columns will like flush at the same point where it is, how it is on this ground floor. So right now I want to copy all my columns. Now to copy your columns now, it is always good to now click on the first column, right click, and then say select similar. As you can see, it has not selected all the columns except these circular columns that came with the plan. So it has selected all the columns. So again, let me go again. Click on the first column, right click, and then you will see this option, select similar. So click on it. It will select all the columns that is there. And then type CP or CO, which means copy. Now go and pick that point of reference. I'll pick this edge now. And then go to this first floor and pick this edge again, which is my point of reference. Now, if you see right now, you can see that all our column points are entering wall to wall. Can you see that? They are all hiding inside the walls. There is no column coming out like this. Let me say column coming out empty space like this. Can you see that? Hello, are you with me? Okay. So had it been as we copied these columns on this ground floor onto this first floor, and there is any column coming out empty space like this, Basically, you are meant to change the color of this column to either any kind of color, let me say magenta, which simply means that this column is going to terminate at the slab, because on this first floor is intended to come out on an empty space, which will cause, let me say, which will cause an issue on this kitchen when they are trying to use this kitchen. Can you see that? So always change the color of any column coming out empty space on your building, so that you will know that this color is to that column. When you go to the to that software and now insert your story, you are meant to remove this column on the first floor, because because now it is causing what they call obstruction on this floor. But since we don't have any kind of column doing that, I'll just remove that. So right now, all our columns are just flushing from wall to wall, as you can see that. Can you see that? Hello, are you with me? Hello, are you with me? Okay, now the next thing now to do is that, okay, looking at this point now on this first floor, knowing that this circular column is not going up to this place. So the question will be, what will carry this area, this beam at this place? And for you to cantilever this beam of 4 meters is not wise to like do that. So the next thing to do is that you are going to establish a column at the at the at this point at this point when you insert on this story. So since I'm going to put this column, since this column it will like sit on the beam of the ground floor beam, I'll change this column color to yellow. So simply means that yellow means that it is a new column I am going to let me say put, or let me say insert on the first floor during my design. So the same thing now happens also on this area, on at this point here, because this point here has nothing carrying this beam here and this beam here. So basically there should be a column here. So since I now have one column here and one column here, that tells me that this column right now we like going to sit directly on this circular column or on the beam around this place on this ground floor. I don't know if you get what I mean. Let me know if you're confused. Can you hear me? I said, let me know if you just get what I just said now. Okay, that's fine. So right now that we have done all our GA and we have copied our columns to this first floor, and we have seen that all the columns are flushing the same points, and we have known that we are going to add 2 new columns when we go to the first floor of our design to be able to carry this point and this point. So right now it is now time for us to now export our building, this our GA, to the software Protastructure. So it is now time that you now begin your own. Now I am done casting my screen. So you now begin to now cast your screen, because I will send you this plan for you to now export it into the software and then begin your modeling, of which I am meant to be with you. But I think we have spent almost 1 hour or so far for this. So what I will do is that, can you hear me? We will do this one tomorrow, which you are going to export it now to Protastructure and then do the modeling. That's tomorrow. But since I have taught you GA, but since I've taught you GA now, I'm going to give you an assignment. Yes, can you hear me? Can you hear me? Yeah, I say since I taught you GA just now, since I taught you framing just now, I'm going to give you an assignment which you are going to do a framing and show me tomorrow, which is a 2-story building, as you can see this one here. So this one now should be your assignment. So do this framing, do the GA, put your grid lines and column positioning on this plan. As you can see that this plan has a ground floor, a first floor, and then a pen floor, as you can see it here. So and also has a cantilever, as you can see that. So make sure you check your plan very well, study it, and then do the same thing that I've just done just now. As you can see, I did this from this plan to this very way as it is here. I did my panel 1, everything, panel then. So do the same thing that we have done today, as you can see for this one, so that when you're done with this design, this is the one you begin to to do your practice. Why I'll be the one guiding you on this one, then you now be the one doing this by yourself. So that let me see how your hands is going, and also how you're learning. So make sure you study this plan very well. As you can see that it has several cantilevers. This is a cantilever, small cantilever here, and on this pen floor, you can see that this is a roof below. So this is the only place that has building on this pen floor. So make sure you study it very well. And then when you also get to this so make sure you do it very well. So first of all, do your GA on this plan. Do the GA on the ground floor, and then copy your columns to this first floor, and then mark the columns which are to stop at the slab, and the columns that are meant to continue. Also, copy the column again to this other one again. Take off all the columns that will come out on this roof area, and leave only the columns that will rest inside the walls on this area. Okay, so let me just close this now, and then I'll send you these two plans now. So I'll just send you this. Okay, I'll send you this one entirely. So this is let me go to the mail. Okay, remind me your email again. Let me see. What's your email again? Your email again. Your email. Can you hear me? Hello. Remind me your email address again. Can you hear me? Yeah, I said you remind me your email address again. Email address. Yes, can you hear me? Can you hear me? Hello, can you hear me? Hello, are you with me? I said you should tell me your listen again. Email address. What's your email address? No, just can't you see my screen? You can sorry, EKE, right? S UDOH, yeah. 635 at Gmail. Okay, so confirm that you have seen. Okay, I've seen that. Now confirm that you have seen these two drawings now. Okay, let me now. I will stop sharing. Why you share your screen now? Let me see if you have received that. So share your screen. Let me see. I'll stop sharing now. Can you hear me? Yeah, I'll stop sharing the screen now. So I'll stop sharing. Can you hear me? I said I want to stop sharing. So share your screen. Let me see if you have seen those two files which I just sent to you. So I'll stop sharing now. Now share your own screen. You will see that rectangle that has an arrow inside. Click on it, and then you will see present now. Sorry, your entire screen. Then click on that entire screen, and then I think you see. Okay, that's fine. Okay, so check your mail. Let me see if you have seen that. check your Gmail. Let me see if you have seen that. Okay, don't worry. If you can't check your Gmail now, you can check it later. But from tomorrow, you will not be the one casting your screen. Can you hear me? Okay, yeah. Okay. So from tomorrow, you'll be done casting your screen. So let me know again tomorrow when you'll be free. All right. So basically, that now I sent you two files. One is the one-story building. Yes, one is the one-story building which I just did, and that two-story building is for your own assignment, which you're meant to do what you just did right now. And then when we come tomorrow, we will now do the like the model and the design of the one-story building which I just sent to you. And then later, after you're done with that, you now use that two-story building and now also practice your own design and also modeling too. All right. Okay. And also we are going to use a part foundation for the one story, and for the two-story building which you are doing, we are going to use a strip foundation for that. Okay, so we'll meet tomorrow again. Any questions so far? Let me know if you have any questions so far. Yes, like yeah, yes. Like let me say, if you have a block now, like yes, it should not exceed 30 meter square area. Yes, that means that at least it should be each panel should be at least 5 times 5. That will give you at least 25, or maximum 5 times 6. That gives you 30, but not up to 6 times 6. No, that will have a failure on that panel. Okay, okay, okay. Yeah, that's fine. So meet tomorrow again, right? Okay. So are you done with your graph design you're doing before? Okay. That's fine. That's fine. Okay, now. So meet tomorrow. Yeah, bye. Okay. Okay, so this is how Ekidel mentorship is. So if you're interested to join our Ekidel mentorship, I would say check on the link down below and then enroll for your Ekidel mentorship, and we will train you basically on structural design. Okay, so bye for now. We love you, and then goodbye.